Bismillahirrahmanirrahim. Assalamu alaikum, dear students, and welcome to PMDC lecture room. Today's lecture is from first year chemistry, chapter number 7, and the topic is Lechatlier Principle. It is one of the most important and repeated topic from examination point of view. In today's lecture, I am going to discuss the following content: introduction and what is an equilibrium reaction, statement, factors affecting equilibrium, and in the end, we will solve an example by applying all the factors we have studied, and you will be given an assignment. The name of the principle is on the name of a French chemist, Henry Louis Lechatlier, who actually presented this principle. He studies the effect of change in different conditions, such as concentration, temperature, and pressure, on a reaction that is in equilibrium. In order to understand the Lechatlier principle, first we have to understand equilibrium. You can see two images over here. In image number 1, there are two objects, object A and object B. And the weight of object A is greater than weight of object B. So there is an unbalanced seesaw and no equilibrium between object A and object B. Now look at image number 2. The weight of object A is equal to weight of object B. So there is equilibrium between object A and object B in this case. Have a look on the statement of Lechatlier principle in order to understand this. So the principle states that change in the temperature, pressure, catalyst, or concentration of a system will result in a predictable and opposing change in the system in order to achieve a new equilibrium state. It means that whenever a chemical reaction or a system is at equilibrium, and at this stage we disturb the equilibrium by changing any one of the following conditions, the system will rearrange and attain a new equilibrium according to the new conditions. There are various factors which affect the equilibrium of a reaction. We will discuss them one by one. First of all, effect of concentration. That how change in concentration can affect equilibrium of a reaction. Let's suppose we have a reversible or a reaction that is in equilibrium. Reactant A and B react together to form product C and D. The half-headed arrows show that there is equilibrium between the reactant and product, and the rate of forward reaction is equal to the rate of reverse reaction. Now what happens if we change the concentration at this stage? So by increasing the concentration of A, the reaction will move in forward direction. Now if we increase the concentration of A, reaction will move in forward direction in order to attain equilibrium and to balance the concentration. Similarly, if we increase the concentration of B, again the reaction will move in forward direction in order to achieve equilibrium. Similarly, if we increase the concentration of product, that is the concentration of C or D, so the reaction will move in reverse direction in order to achieve the equilibrium and to balance the concentration. Similarly, if we decrease the concentration of reactant either A or B, again the reaction will move in reverse direction. Now what happens if we remove the product from the reaction? If we remove the product, so the reaction will move in forward direction to attain the equilibrium and balance the concentration. Second factor affecting equilibrium is the effect of temperature. We all know that there are two types of reaction: endothermic reaction and exothermic reaction. Endothermic reaction are those reactions in which heat energy is absorbed It means that heat is reactant in this case. Exothermic reactions are those reactions in which heat energy is released, which means that heat is product in this case. So the effect of temperature is different in both these cases. According to Lechatlier Principle, if a system is at equilibrium and we increase the temperature of the system, so the system will move in the direction of endothermic reaction. In that direction in which endothermic reaction take place. Similarly, if we decrease the temperature of a system, so the reaction will move in that direction in which the reaction is exothermic. Now to understand the effect of increase and decrease temperature, let's take an example. You can see an equilibrium reaction in which A and B react together to form C and D. The reaction is exothermic. Delta H is minus 250 kJ per mole for this particular reaction. As the reaction is exothermic, so according to Lechatlier principle, if we increase the temperature of this particular system, so the reaction will move in endothermic direction. As this reaction is exothermic in forward direction, so this reaction is endothermic in reverse direction. This reaction is endothermic in reverse direction. So by increasing the temperature, the reaction will move in reverse direction. Similarly, what happens if we decrease the temperature? So if we decrease the temperature of this system, the reaction will move in the direction of exothermic reaction. And in this particular case, by decreasing the temperature, the reaction will move in forward direction because this reaction is exothermic in forward direction and endothermic in reverse direction. The third effect is the effect of pressure on equilibrium reaction. As we know that in case of solution, pressure has almost no effect on equilibrium. But when we talk about gases, so gases are greatly affected by change in pressure. So according to Lechatlier principle, what happens if we increase a pressure? So by increasing the pressure, the system will shift its equilibrium in a direction of reduced volume or reduced number of moles. Let's understand this with the help of an example. So you can see in this diagram, by increasing the pressure, the volume of the gas get decreased. And by decreasing the pressure, the volume of the gas get increased. As we know that the pressure and volume has inverse relation. So increasing volume, decrease pressure. Decrease in volume, increase pressure. Now look at the example. In this example, there is an equilibrium reaction between A and B. The product is C. All the reactant and products are in gaseous state. Let's suppose we have 1 mole of A and 2 mole of B. Total 3 moles, or we can say 3 volumes on reactant side. And on the product side, we have only 1 mole of a gas or 1 volume. So the ratio is 3:1. According to Lechatlier principle, by increasing pressure, the equilibrium A will shift in the direction of decreased volume or decreased number of moles. So in this case, by increasing the pressure, the reaction will move in forward direction and more C formed. Similarly, by decreasing the pressure, the equilibrium will shift in the direction of more volume. So in this case, by decreasing the pressure, the reaction will move in reverse direction in order to achieve equilibrium. The last factor is the effect of catalyst. As we know that the Function of the catalyst is only to speed up the rate of a chemical reaction. So there is no effect of catalyst on equilibrium of a chemical reaction. It only speed up a chemical reaction. Now there is an important industrial process called Haber process, which is used for the formation of ammonia. This is one of the example or application of Lechatlier principle. So in Haber's process, 1 mole of nitrogen react with 3 mole of hydrogen molecule and formation of 2 moles of ammonia take place. The reaction is exothermic. So according to Lechatlier principle, how we can get the maximum amount of ammonia? So as we know that on the reactant side there are 1 mole of nitrogen and 3 mole of hydrogen. So we have total 4 moles on reactant side. And product side there are only 2 moles. So the ratio is 4:2. So by increasing the pressure, the reactant will move in the direction of decreased volume. It's mean that in this particular example, if we increase the pressure, the reaction will move in forward direction and more production of ammonia take place. Now what is the effect of temperature on this particular reaction? So we know that from Lechatlier principle, by increasing temperature, the reaction will move in the direction of endothermic reaction. As this reaction is exothermic in forward direction, so this is endothermic in reverse direction. So by decreasing temperature, the reaction will move in forward direction and more production of ammonia take place. So this reaction is favored by low pressure, low temperature and high pressure. And what about the concentration? So if we remove ammonia from this reaction, so by the removal of ammonia, more ammonia formation take place. So to get good amount of ammonia, we need high pressure, low temperature and removal of ammonia in this particular case, which is one of the application or example of the Lechatlier principle. I hope you understand the topic. So if you understand, then you are able to solve the assignment. Thank you.